Today we're going to review line equations and the slope formula and look at equations from a graph. So the slope formula. Slope is represented by a lowercase m, and the slope formula, if we are given 2 points, let's call them x1, y1, and x2, y2, the formula is, in words, it's the change in y over the change in x. So what that looks like is y2 minus y1 over x2 minus x1. And just a couple things to point out. It really doesn't matter if you start with y2 or if you start with y1. But if you start with y2, you have to start with x2. You have to go in the same order or you won't have the correct sign when you are done. And also remember that it's the y values that are in the numerator and the x values are in the denominator. It's rise over run. So you have to be careful for those two things. And then as always, when you're subtracting negatives, you have to remember to change the sign. So we use the slope formula in what we call the slope-intercept form of a line equation, and this is the one that most students will know. Y equals mx plus b. So m is the slope, and b represents the y-intercept. That is where the line crosses the y-axis, so it has a coordinate of 0, b. That's the formula we usually use when we are trying to compare slopes, when we are trying to graph a line, and when we're trying to write a line from a graph. That's typically the form that we use. But there is another form that you're going to use later on, and it shows up quite a bit in calculus when you get there eventually, and that is called the point-slope form. So that's what I'm going to show you next. Okay, the point-slope form of a line equation is very helpful when you have just 2 points. So when you're given 2 points, and let's call that again x1, y1, and x2, y2. What you have to do is first find the slope. So you would calculate the slope. But then, instead of going back and trying to find a value for b, all you have to do is choose one of these points and put them in this form. This is handy when your b value isn't a very easy number to find. If there's a lot of complicated fractions, we don't have to go that route. So this is point-slope form of a line equation. It looks like this: y minus y1 is equal to m times the quantity of x minus x1. The variables are y and x. So those are still the variables, just like in y equals mx plus b. And then y1 and x1 come from the original point x1, y1. Now it doesn't have to be y1 and x1, that's just the notation for the formula. You could have chosen x2 and y2 to substitute in, but this is point-slope form. This is used in calculus, and it's much easier when you're looking for a line equation and you're not so concerned about the y-intercept. So I'm going to walk you through an example using the point-slope form, because this is going to be new to you. So it says, write the equation of the line passing through 310 and 27. What I typically do is I label my points x1, y1, x2, y2. The first thing you have to calculate is the slope. So the slope is going to be 7 minus 10 over 2 minus 3. You could have also reversed it. You could have said 10 minus 7 over 3 minus 2. You end up with negative 3 over negative 1, and that ends up being a positive slope of 3 over 1. Then all you have to do is just one step from here to write the line equation if you use slope or point-slope form. So the line equation, if I choose 3 and 10, you could have also chosen 2 and 7. It's just this: y minus 10 is equal to 3 times x minus 3. That's one version. An equivalent answer would be y minus 7 is equal to 3 times x minus 2. Either one represents the same line. And again, that is point-slope form. So we have some special line equations we need to go over because we're going to use them quite a bit in this course. The first one is how we represent horizontal lines. Horizontal lines are functions. You can graph them on your graphing calculator. They pass the vertical line test. So horizontal lines are actually represented by a y equals. So we say y equals b because they're going to cross the y-axis. So if I have a little mini x and y axis here, a horizontal line is represented by a y equals equation, y equals b. So if I want to graph the equation y equals negative 2, it's going to cross the y-axis at negative 2. X can be anything you want. Y is always negative 2, so that's what that line equation looks like. Now vertical lines are not functions. Vertical lines are x equals equations, x equals a. So they cut through the x-axis, they are parallel with the y-axis. You cannot graph them on your calculator. So if I graph x equals a, he's a vertical line. That's what he looks like. A numerical example, if x were x equals 3, he would cross the line at x is 3 and be vertical. So it's important that you understand the difference between horizontal lines and vertical lines. We can also obtain line equations from a graph. To do this, the easiest thing to do is to find the slope and find the y-intercept. And then you're going to put them into y equals mx plus b. So I usually find the y-intercept first. If you look at this graph, my y-intercept is right here. That's a coordinate of 0 and 1, 2, 3, 4. So it's 0, 4. That's the coordinate of the y-intercept. So the b is going to be 4. And then to find the slope, I'm going to count my y values. Looks like I'm down 2 to the right 2. So as you see the slope, as I move left to right, the line is decreasing. So it's going to be a negative slope. And it's going to be negative 2 over 2, which simplifies to negative 1. So this line equation, when I'm finished, is going to be y is equal to negative x plus 4. And finally, to write the equation of this line, we first have to decide if it is a y equals line or an x equals line. And if you think about it, it is a function. It passes the vertical line test. So this is going to be a y equals. It crosses through the y-axis, and it crosses at 1, 2, 3, 4 at negative 5. So this line equation is y is equal to negative 5. In class, we'll be practicing more. We'll be calculating slopes, and writing line equations and practicing the point slope form a little bit more.